Our next speaker is called Manoworm, and she will take us back in our childhood, our youth. Everybody of us will feel 20 years younger for the next half hour or so. It is a dive back in ringtones, so
not quite yet.
I'm excited to hear all those old tunes again from my past. Please give a warm applause, a warm welcome, and I'm very excited for this next talk. Thank you.
Okay. Hey folks, yeah, thank you all for coming and for the warm welcome. You might have seen my profile on the Fediverse, so I'm Manoworm at chaos.social. I'm usually busy hacking away at some old exotic retro hardware or doing GSM, ISDN networking, or in my day job, I'm keeping one of the cloud providers up and running. Most of the projects we do are released as a part of a group called Kitten Labs, which is run by my girlfriend Annie and me. Some of the projects we've done include hacking a TP-Link Wi-Fi router to play GTA. Annie chopped the Wi-Fi chipset traces and replaced them with a mini PCIe slot, and then we connected the GPU. We also ported the TCP IP stack to common Casio calculators you might have had in school, and we ran a web server on those. And last but definitely not least, these are the wonderful blinker cards from Annie, which you might have seen around at some of the last Chaos events. Wisely meshed RGB mood lights, and you can play and interact with them. But back to Blåmba. So how did we even get here? It all started back in 2021 on Twitter, way back before it was bought by a certain individual with more money than sense. My friend Nick, you might know him from his DJ sets, there's one going on right now, posted this tweet. He'd gotten himself a Nokia 6310 and a SIM card, and he was just asking for regular phone calls, just phone calls and SMS from his followers, just for fun. I did remember, SMS could contain a lot more info than just text. I began a search through the internet. I looked at old specification documents, Wikipedia articles, and eventually I ended up with these short messages. I sent them to Nick's phone, and, well, what do you know? A new operator logo appeared. Fun. Of course, well, this wasn't all. I've played around a bunch more, and then I managed to send a ringtone. So, time for a little family picture. These are some of the Nokia phones I own, not all of them by a long shot. I swear, I don't have a problem. I grew up using the Nokia 6210 and later the 6220 and later the 6300i. So most of my life, up until smartphones, has been pretty Nokia-centric. Some of the info about smart messaging today will be Nokia specific, but most of the WAP stuff will also work on other devices. Over the time, the capabilities of these phones have changed quite dramatically. So the first Nokia phones were only able to receive little black and white logos, 72 pixel by 14 pixels large. They could also receive little monophonic ringtones, just a single note at a time that they played back as a square wave. A little bit newer phones, still with the black and white displays, could then also receive the first early Java apps, so J2ME apps. Those phones really didn't have much storage, on the order of 64 kilobytes, so the complexity of those apps was really limited. Later on, from about 2001, 2002 onwards, phones would support much more features, so they could play back monophonic ringtones with different instruments at the same time, typically just MIDI files. Many of the phones gained full web browsers, so they could support for the typical web file formats, PNG, JPEG, GIF were all supported. And even a while later, they gained support for MP3 and AMR audio files, so just sampled audio. And around the same time, phones also became capable of recording video with the built-in cameras, so those phones could record and then also, of course, decode early video codecs, so H.261, H.263 in container formats of the time, so something like 3GP. All those file formats are nice, but, well, how do we send binary data to old phones, especially to old phones without internet access? Well, via SMS. SMS have a special feature, and the special feature is called the user data header. You can set a specific bit in the header, and then the start of the message is parsed as a binary format, as text, length, value, encoded little packets. They are called information elements, and these information elements can be present multiple times, so a user data header can have multiple of these information elements with different functions. If we look at a list of these common user data header information elements, those are not all, we can see things like concatenated short messages, application port addressing. One of the most common use cases of user data header was concatenated SMS. So if you wanted to send an SMS that's longer than the maximum of 140 characters that will fit into a single message, you can set the bit to indicate we have a user data header, and you set a single information element which includes a reference number, so which SMS is this, the total number of parts you want to send, and the current part that you are sending. And this header is then just followed by the normal plain text of the SMS, and each following part starts with the header again, with the same reference number and an incremented part ID. Now we're getting into the fun stuff. So Nokia made their own specification called smart messaging in the early 90s or late 90s, which includes a concept very similar to TCP/IP ports. So they have a 16-bit wide port, and the phone will respond to different ports with different handlers. With this information element, you can send binary data to specific ports on a phone. If we look at the spec, we can find such a listening port as hex 1581. And if we just send a ringtone to port 1581 on a Nokia phone, it'll accept it and then show it as a ringtone. Operator logos are another one of those features. So each network provider is identified by a mobile country code and a mobile network code. So for example, in Germany, we use country codes 262. And for example, network code 1 would be Deutsche Telekom. We can send black and white logos along with a country code and network code pair of an operator, and the phone will save that and display this logo instead of the network name when it's connected to this provider. But we can send any image we want. So this is what an operator logo would look like via SMS. So we have a length indication at the start of the user data header. In this case, it's 0B, which is 11 bytes long. We have an information element for the port addressing, so 16-bit port, where we can see that the destination port is set to hex 1582, which is the operator logo port. And after that, we just have one of those concatenated message IEs again, because the operator logo doesn't fit into a single SMS, so we need two. And this is the first part, the first message out of two parts. And in the next SMS, there is the current part incremented by 1, same reference number, just with a higher part ID, and of course the next part of the payload. If we send such a message to a phone, we'll get this. You can see the two parts there. Yeah, so not all networks, especially in the early days of mobile phones, were 8-bit binary safe. So they could, or some of them, could only transfer ASCII characters. Nokia built another hack for that, which is called the SCKL format. It's a plaintext header, which we can use to send binary data to the same ports, and just by sending an ASCII message instead. So an ASCII message with the SCKL header, then the port, and then just hex encoded nibbles. This is very inefficient, of course, as you need 2 characters for each byte you want to send, but it does work. It's just a long SMS in the end. Another Nokia standard that became very common is the ringtone text transfer language, the RTTL, which is a plaintext file format, which is super common for monophonic ringtones. So it just stores a ringtone name, some settings like the default duration of a note, the octave, the playback speed, and then just a list of musical notes. And you can find a lot of those on the internet. But how do we actually turn those RTTL files and some images that we have into binary data we can send via SMS? Luckily for that, there's ringtone tools written by Mike Cohn, a very powerful program which he wrote back in 2001 already. It has a support for an absurd number of file formats, both for input and output, and just an equally large number of command line switches to toggle various features. And this is what Blåmba uses internally to convert all the images and ringtones into SMS data. So how do we actually send these? Now we have all this knowledge about binary encoding, user data header. The big question is, where do we go from here? So question to the crowd, raise your hand if you've ever used AT commands. Okay, that's about half actually. So for those of you who haven't used AT commands, back in the early 80s, a company called Hayes created a de facto standard protocol for talking to modems. And this protocol standard was then later also carried over to mobile phones and other devices. Well, in fact, even today, chances are pretty good that your device will use AT commands internally to address its cellular modem. If we have a device that's already connected to network, for example, a 3G or 4G USB dongle, we can use that to send these SMS messages. They will just expose an AT command interface over a serial port. Many old phones will do the same over serial. We can tell an old phone or a 3G dongle to switch into a raw packetized mode and then just send it hex-encoded bytes. And this is a bit more complex because we also need to include all the SMS header itself. So we don't only need to use the data header, but we need to include the destination number, numbering plan, data coding scheme, etc. A more direct way that we have for sending SMS is the short message peer-to-peer protocol, SMPP. So if we have a friendly mobile network operator or we are a customer of a commercial SMS provider, you can get access to an SMPP server. So it's a binary protocol, you open a TCP socket, you send the authentication, and after that you can just feed raw SMS right into this connection. And this is what would happen internally in GSM networks. For example, if we are looking at the open source Osmocom GSM stack, you can connect to Osmo MSC, the mobile switching center, via SMPP, and just send SMS that way. Well, all of this binary encoding is super annoying. Implementing AT command state machines, encoding raw SMS headers, talking to SMPP sockets, it's just a bunch of work. Thankfully, this has already been done for us in a wonderful project called Canal. Canal is an open source WAP and SMS gateway. So these two parts are mostly separate. We'll talk about SMS for now, and then we'll cover WAP later. Canal is split into three main daemons. So it's core called BarraBox, the SMS gateway, which they call SMS box, and the WAP gateway, which they call WAP box. So the Canal is actually enterprise-grade software, the good kind. You can tell this software has seen prod workloads over the years. It really does just work. Canal's SMS gateway, the SMS box part, can be configured to talk with modem through AT commands. It can speak SMPP, about 10 other exotic protocols to handle SMS. And you can just install Canal on a machine, tell it where to find a modem on a serial port or where it can find an SMPP server, and then it will expose an HTTP API to send and receive SMS. Canal will handle all the nasty encoding work, will deal with queuing and all the quirks around AT commands. It's very nice. And now we have all the parts. We know how to generate the SMS payloads. We know how to send them. We need some kind of web interface. So this was quickly hacked up using a very classic PHP MariaDB tech stack. The only notable part here is bubble wrap. As you might imagine, running 25-year-old C software on input from a bunch of hackers at a hackercon is not a good idea. So bubble wrap just executes the CLI tools like ImageMagick and ringtone tools in a sandbox with very little permissions and with seccomp-based syscall filtering. And so please don't use Blåmba as a capture the flag challenge, but if you do, please tell me about it. Yeah, in case you really want to know the details, you can find the code on GitHub or just ask me. It's very dirty proof of concept code. Please don't expect much, but all the interesting parts are located in the libs folder. In case you haven't seen it, this is what Blåmba's web interface looks like. So www.blåmba.de. It's a one-to-one clone of one of the major providers back in the early 2000s. You can register your device to a browser session or cookie by sending a registration SMS to Blåmba, and after that, you can use the web interface itself to send content you want to your device via SMS. And you can also use Blåmba just with your retro phone itself by choosing your favorite content from either the website or the advertising posters are made, and then just send the 5-digit content ID to the Blåmba phone number, and the same web interface code will then also handle your incoming SMS and reply with the appropriate content. So, monophonic ringtones, tiny black and white logos, those are fun and all, but nowadays there are these newfangled phones with color screens and MIDI support on the market now. And for all the content that doesn't fit into a couple of SMS, we'll need to look into WAP. So, WAP, the wireless application protocol, describes a number of different protocols and standards, but in the end it's a stripped down version of the regular web. So with stripped down HTML, they call it WML. It's still XML based. It's still hosted on regular HTTP servers. It still uses regular URLs, GET and POST requests, just like we're all used to. Early phones, like this one, they weren't powerful enough to handle a full TCP/IP stack and parse the WML XML themselves. And that's why a so-called WAP gateway was introduced. The WAP gateway accepts simple request response packets, just one packet at a time, and in a format they call WDP, the wireless datagram protocol, and it will translate them into regular HTTP calls. And this the gateway will also try to parse the WML XML, and it returns binary tokens, so just the binary representation they call WAP binary XML. Back when WAP was standardized, there were a number of different cellular standards. So WAP can be used over many different protocols like GSM, CDMA, TDMA, even over DECT. I've never seen a WAP-capable DECT headset, but the spec exists. So, yeah. But when WAP is used over GSM, it would typically be used over GPRS or via CSD. WAP over GPRS is the simplest transport layer. So the cell phone uses regular GPRS data, like we all know today, to send and receive those WAP packets as regular UDP packets. Sometimes fragmented, but regular UDP packets. Circuit switch data is an older mechanism to get data access on phones. You can think of circuit switch data as a modem call over GSM. So it's not really a modem call, it's fully digital, there are no analog modems involved, but the phone will place a call to a phone number, similar to a regular voice call. Instead of the voice codec, it will send digital data. Inside this connection, regular PPP is used again to get packet switch TCP/IP connectivity. At least in Germany, CSD was switched off on all carriers after 2023, and the base stations we use here for C3 GSM, they can't do it right now either, lack of software support. So right now the only way to get working WAP over CSD is either in a different country like the UK, where they still have a single operator that does it, or via a software-defined radio GSM base station, which now does support CSD with the Osmocom stack. Yeah, okay, and then the last piece of the puzzle is a WAP gateway. So back in the day, your mobile carrier would have a WAP gateway for you, which your phone could use. They would also do things like handle billing for premium services. So if you visited a site that would cost money to visit, they knew what customer you were and could do the billing. But of course, in 2024, no such WAP 1.1 gateways are available anymore. And this is again where Kernel comes in handy. It can accept those requests, those fragmented UDP packets on port 9200 and proxy them into regular HTTP requests. It can also do the WML to binary XML conversion for us. And for Blåmba, we run such a gateway publicly on the Blåmba server. So if you have a phone that still uses the old WAP 1.1, and requires a WAP gateway, just point it at the IPv4 address of Blåmba and it should work. The IPv4 address is also mentioned in the FAQ. But yeah, of course, in the 2000s, we got much more powerful phones with color screens, more capabilities, and these newer phones, they can skip this whole business with WAP gateways, UDP packets, and they can just use TCP/IP and HTTP directly. So they will just download the full XML, the full WML, and they will parse it themselves. And this also means that the transport protocol is then less relevant. So later phones like the 6300i, they could just even use Wi-Fi for this. With all this WAP stuff sorted, downloading more advanced content becomes pretty straightforward. So we just have to point the phone onto a regular web server with files, so like MIDI, PNG, Java archives, and it'll just start to download and save them correctly. Manually typing those long, complex HTTP URLs is, of course, a bad user experience. There's a feature to help us out here, which is called WAP-Push. And similar to Nokia Smart Messaging, we can also put small WAP messages right into an SMS. Back in the day, mobile carriers would host a thing called the Push Proxy Gateway, PPG, which would accept requests from the internet, convert them into an SMS, and send those to the user. Nowadays, we can just skip this step and format our own SMS and just send them to the user directly. There are 3 types of those WAP push messages. The service indication is the most common type, which will open a little window similar to an incoming SMS, telling the user, hey, there's a new URL for you. Service load will cause a device to just start a network connection and download a URL without any user interaction. As you can imagine, this is disabled or heavily restricted on most devices because it has severe implications. And the cache operations flag is an interesting one. This will invalidate a specific cache for a URL, so you can send an SMS to a phone and tell it, hey, this URL is now has changed. You need to reload it again. For Blåmba, we of course use the service indications. They are very simple. They just contain a URL, a description, and the creation date. Sending the raw XML via SMS would of course get expensive and annoying again. So we can use WAP binary XML again. We just tokenize the message into WAP binary XML, put it together with the appropriate user data header, in this case port decimal 2948, WAP-Push, and send it to the user. And then we get a service message. Every HTTP request a phone sends has a special header that's called a WAP profile, XWAP profile, which contains a URL to the phone's manufacturer. So these URLs were hard-coded in the phone's firmware, and the manufacturer hosts a small XML file on the servers. In this case, Nokia used to host the description file for their 6220 phones. And these files contain a lot of info about the phone, so including supported file formats, display resolution, trusted support. By now, of course, all these URLs are long gone, but the Wayback Machine has a bunch of them. So for Blåmba, we just tried to download as many of these files from archive.org as possible, and we parse them locally. This is what the file looks like. It's just a bunch of info about the hardware capabilities, software capabilities. And in this case, you can see the phone only supports MIDI audio, not MP3 yet. It can also accept Java files, and it has a 128 by 128 pixel screen resolution. So now that we know how it's done, let's go sign up to Blåmba and download some content. We send a registration SMS. (252622) is Blåmba. We can refresh the page to see that we have a new MSN that's now registered. And then we can just go through the web interface, look for some content that we want, in this case a ringtone, click on the ringtone, and send it to our device via a WAP-Push service indication. Blåmba also always shows you the data, so you can have a look at it yourself. We're all nerds, we want to know how it's done. There's a service message. These phones don't have a progress indicator on the download, so it just shows until it's done. And then we have a ringtone. If you're now thinking, this sounds pretty fun, I want to play with it myself, well, you can. Blåmba has a feature called manual SMS, where you can just put in hex data of your own choosing, and it's just a raw user data header and your payload, and Blåmba will send this right to your phone. You can send pretty much anything you want, but just remember those phones are running software from the 90s with the security problems of the 90s, so they will crash pretty badly if they see unexpected content. Behind the scenes, just to get an idea of the service status, we have a Grafana dashboard. The PHP application for Blåmba just exposes the Prometheus exporter as an HTTP endpoint, which gets crawled regularly. To actually make Blåmba work in the field, though, we've deployed one of these little gateway boxes. So these are standard PCs with a 3G USB dongle. They run kernel, they connect to a VPN to the Blåmba server, and then we just send and receive those HTTP API calls I've mentioned. On our first installation at the 2023 camp, we've used this Intel NUC. My thought process was, it's an x86 box with Intel Ethernet NIC, it will be much more reliable than those single board computers. What we didn't know or realize at the time is the 219 NICs used in those has a hardware bug, which will crash the Ethernet after some time. So the fix is just to disable the offloading features, but having to physically walk over to a tent on the other side of camp at 35 degrees Celsius outside is just a debugging nightmare, and especially without a keyboard or mice. We then switched over to Raspberry Pi Compute Module 4 in a nice metal enclosure. It has external antennas for better reception, a PCIe Wi-Fi card, but it's still using the same 3G dongle. In our testing, we also found that the common Huawei dongles didn't seem to work very well. For SMS stuff, at least, we used a ZTE dongle, and that worked very well. The community came up with a bunch of nice chaos-related artwork. Thank you very much. If you have an idea for cool artwork, just please create it, and there's guidelines on how to create artwork in the Blåmba content ingest repo. Yeah, you can see it there. Thank you very much to LaForge, Billy, Nick, Benjamin, Mike, Cohn, Jennifer, the Osmocom team, ImageMagick, Canal. All of these tools were wonderful and absolutely mandatory in making this happen.
Thank you very much for this talk. We are open for questions now. Yes, microphone number 2.
Hi. Thank you for the talk. It was amazing. I'm just curious, since most of the stuff that's sent is over SMS, how much of it, like the ringtones, the carrier logos, are supported by a modern smartphone? Or they just ignore it?
Yeah, none at all. They just ignore it completely. So if you send this to an iPhone, nothing happens at all. You see nothing.
Thank you.
Yep.
Microphone number 3, please.
Thanks for your talk. I'm just interested to hear, since putting up this service, has anyone from Jambar or any of those old services reached out to you?
No, thankfully not yet. I'd expect they wouldn't be too happy about it, but I guess it's a parody.
Are you ready for some questions from the internet?
Sure.
All right. Please, our signal angel.
Okay, the internet wants to know, does it send SMS over the regular phone network, or would it, if you were to connect it to a regular phone network, would that work?
Yes, that absolutely does work. Of course, you need a SIM card for a regular phone network and ideally a flat rate for sending SMS. I've tried it with a bunch of German networks. It works perfectly well. I just suspect that the providers wouldn't be very happy if we offered this as a public service and misuse their flat rate to send these messages.
Looks like we have answered all the questions. Thank you very much for this talk.